You can download this exact automated template completely free. The link is in the description. All I ask is that if this saves you hours of manual work, hit that subscribe button so you don't miss the next automated tool I will build for you. Good day, today is Tuesday, which means we're going to build a brand new, highly useful Excel template for e-commerce supply planning. First, let's build our master data. We were able to tackle this on our inventory tracker tutorial. This tab is the literal DNA of your tracker. Row 3 holds your fundamental pillars: item code, SKU, description, fulfillment center configurations, specifically FC1 code and FC2 code. Warehouse location, units per case, cases per pallet counts, supplier names, late time, and New York COX. Next, let's build our forecast tab. This tracks your horizontal sales demand forecast month by month all the way through 2026. You will notice that on row 3, we created a helper row. It uses a specific helper formula that's now flashing on your screen. On your main PO tracker, we will use a daily date, and in order for us to link a specific day to its corresponding month and year on the forecast tab, we use this shared date code. I'll show you how we add this go to the tracker later to complete the data linkage. For now, remember that this forecast tab has simply a raw data dump pasted from a separate, finalized forecast template. In the future supply chain tutorial, I'll teach you how to build a forecasting template from scratch. For this sheet, the format is entirely up to you, as long as it is easy to link back to the main PO tracker. Now let's build our in-transit tab. Which also tracks item currently in production. This sheet captures everything currently being manufactured or moving across ocean freight, so your timeline knows exactly what supply is on its way. It consists of the SKU, item name, order quantity, the warehouse reference column so you know where the stock will be stored if you run multiple facilities. And finally, it includes ETA, or estimated time of arrival, which is the exact metric that drives where these quantities land on our horizontal PO timeline. And last of our raw data tab is the inventory summary tab. This is a clean snapshot that isolates total available warehouse units and your fulfillment center inventory, both available and in transit to fulfillment center. If you watch our previous tutorial on how to build an inventory tracker, this functions exactly like the inventory summary section. It summarizes your main warehouse stock, links to your raw data, balances your FC1 and FC2 inventories in dedicated columns, and reference your in-transit volumes. If you built your inventory tracker following our previous guide, you can easily link this column directly. But for now, this tab will serve as a raw data dump copied from your latest inventory snapshot. Get these supporting tabs established first because they feed directly into our ultimate automation sheet, the PO planning tracker. Now let's look at the heart of our spreadsheet. Let's start building our main PO tracker. Instead of just a simple flat list, we build this tab using a highly structured horizontal row matrix for every single product line item. So let's decode exactly how this rows function step by step from row 5 down to row 14. Number of days per month. This tracks exactly how many calendar days are in the current active month. like 31 days for August or 30 days for September. It uses the formula currently flashing on your screen. This allows our formula to dynamically convert monthly forecast demand into a precise daily velocity. Since sales projections are typically set monthly, we must determine the average daily sales for that month by dividing by the exact number of days. While other trackers simply uses a flat 30-day average, we use this formula to stay completely precise. Next is the row 6 date code. This helper row matches your daily timeline up to your horizontal forecast metrics I showed you earlier. Since individual calendar days don't match the monthly layout of the forecast, this code determines exactly which month and year a specific day belongs to. Row 7, header, and timeline. The first 4 columns map out your core product details. So cell E7 indicates that all subsequent data across row 7 will be calendar dates. So this timeline starts on the exact date you download your raw inventory data, and in-transit date, which we anchor to cell A2. Remember to update the date at cell A2 every single time you download fresh data to ensure everything aligns perfectly. If you pull your warehouse inventory on August 26, your FC1, FC2, and in-transit data must align to August 26 as well. To make this automated, cell G7 and all following cells use a formula linked to cells at 7. Since it's just a daily tracker, we just simply add 1 day to the previous date and drag it across for a full year or more, depending on your planning horizon. Row 8, which is the beginning inventory. This calculates exactly how many units you have starting on that specific day, automatically rolling over from the previous day's ending calculation. Row 9, in transit. Post live data from your in-transit raw data tab, showing the exact day an arriving batch hits your warehouse inbound dock. Row 10, which is the beginning DOS or days of stock, converts your starting unit inventory into an actionable timeline, telling you exactly how many days of runway your stock provides before hitting MRE. Row 11, forecast. It pulls monthly data from the forecast tab using the SKU and date code as references, then divides it by row 5 to establish your daily burn rate. Row 12, which is the reorder quantity. This is our automatic call to action column. When your stock timeline falls below the safety levels you set, this cell automatically triggers an order volume equal to or greater than your supplier's MOQ. Row 13 are your ending BOS, days of stock, the final safety barrier. It evaluates your total available inventory, subtracts your forecast consumption for that day, and adds any expected incoming shipments, giving you a real-time future prediction of your ending days of stock. Your V order date. This is an advanced back calculation metrics line that shifts backward along your timeline by your exact supplier lead time, telling you the exact date a purchase order must be submitted to ensure it arrives on time. Please note that as we build out this template, we will be leveraging intermediate to advanced formula to make the automation work seamlessly. If we encounter a formula or a piece of logic today that you don't fully understand or need clarification, please let me know in the comment section. I will be glad to respond to your comments to explain it to you, or even create a completely separate video breaking down that specific function. But for today's tutorial, our main focus is going to be on mastering the core concepts and architecture of building a highly functional supply chain engine. Once you understand the workflow logic, the formula will fall right into place. Now that our architecture is locked in, so how do we make these tabs stalk each other? so let's write the map. First up is the forecast row. To make this slightly column dynamic, we use a compound index and match formula. This formula looks up your SKU on the Forecast tab and returns the value at the exact intersection of your SKU code and your timeline's date code. In this example, our SKU is A18929 and our date code is 8-2024, which stands for August of 2024. On our Forecast tab, that intersection yields a monthly forecast of 10,697 units. Because we need a daily rate for our timeline, the formula divides the figure by our number of days per month and cell F5. So that is 10,697 divided by 31 gives us 345.1 units per day. We copy this formula all the way across our columns. Next, let's write the formula for your in-transit row to automatically map incoming ocean freight or production batches. So this formula scans your logistic sheet for matches against your current SKU and the exact calendar date in row 5, automatically pulling and summing the quantities. Now let's look at the beginning inventory. The formula in cell F8 is different from the rest of the succeeding cells in this row. Cell F8 directly links to and copies your inventory from the Inventory Summary Raw Data tab for that specific line item on that particular date. This is why it is extremely important to have your downloaded data match the date you input in cell F7, which is also equal to cell AU. So using the VLOOKUP formula, for this specific item, A18929, the initial inventory is 18,365 units for August 26. For the succeeding cells starting cell G8, the formula updates dynamically. It takes the previous day's inventory, subtracts your potential sales for August 26, adds any arriving inventory from in transit, and includes the quantity you might potentially reorder. So for this line item, the math works out to 18,365 minus 345.1, which is your sales for August 26th, plus 0, this is the in-transit, as we don't have any incoming shipment for August 26th, plus 0, reorder quantity, meaning no planned orders arriving that day. So this equals 18,020 units. Remember the difference between these two metrics. In-transit quantities are units that have already been ordered from the supplier and are currently being manufactured or shipped. On the other hand, reorder quantities are potential, planned, and suggested orders only. They are not yet final. They are simply computed and suggested by the system to fill supply gaps whenever your stock levels fall below the minimum threshold. So therefore, our beginning inventory for August 27 rolls over to 18,020 units. Next up is beginning DOS, days of stocks. This simply divides your beginning inventory units by the daily forecast sales units. For August 26, that is 18,365 divided by 345.1, which gives us 53.22 days of supply. Finally, for ending the OS, the formula calculates your remaining runway at the end of the day. It takes the ending inventory we computed earlier for cell G8, which is 18,020 units, divides it by your daily forecast sales rate of 345.1. So 18,020 divided by 325.1 leaves us with 52.22 days of stocks. Now let's look at our threshold and parameters located in sales B10 through B12. This serves as the checkpoints that dictate when and how many our reorder rows will trigger a purchase order. So let's look at them one by one. Reorder. This is your pre-decided or computed optimal number of days worth of stock to purchase when a BO is triggered. In this example, we order 30 days worth of stock. This means if an order is triggered to arrive on August 26, the expected quantity will be 30 multiplied by 345.1, which is our daily forecast for August 26. Minimum. This is the lowest point your inventory should ever fall. Everything lower meaning a potential out-of-stock risk in the future, or an overly tight schedule that could force you to pay for expensive air freight. Maximum. This is the absolute ceiling for your stock. Exceeding your maximum inventory target triggers unnecessary storage costs, ties up capital, and introduces risk like spoilage or expiration if you are selling perishable goods. So how do we determine these thresholds? Your reorder quantity DOS is generally driven by your supplier's MOQ and your business cash flow. We start by aiming for a month's worth of inventory. Check if that value clears the supplier's MOQ, and then evaluate how that purchase impacts our cash flow versus our container shipping costs. If your reorder parameter is set to 30, your ordering frequency will naturally match that time frame. That leads to a vital checkpoint. Is it cost-effective to ship containers every 30 days? Balancing these factors will reveal your optimal reorder point. Your minimum represents your safety stock. Because you order every 30 days, your new stock will not arrive until your current inventory depletes or the slower baseline. Your team must calculate this minimum by considering standard transit delays, port congestions, PO approval loops, and quality assurance lead times. This cushion catches real-world delays without letting you overstock nor stock out. Your maximum is typically the sum of your reorder DOS and your minimum safety stock. Once you have carefully calculated those two variables, adding them together gives you a safe, reliable maximum threshold. Now we go to our master trigger, which is the reorder quantity row. So we build a logical if statement anchored to your minimum days of stocks. So our reorder volume logic always monitors your beginning days of stocks. If your beginning DOS drops below or matches your minimum threshold, this formula instantly triggers a shipment arrival on that date, equal to your reordered BOS multiplied by that month's daily forecast. It evaluates the exact units required to return your inventory to its maximum target and compares it against your supplier's MOQ, returning whichever number is higher so that you always clear your vendor's ordering constraints. So once retained, drag this formula all the way to the right. Now let's look at our visual alerts. You will notice that on row 10 beginning days of stocks, we created a conditional formatting rule that highlights sell in blue whenever our runway hits or drops below our minimum threshold. To set this up, go to Home, Conditional Formatting, click New Rule, use formula to determine which cells to format, and in the formula field, type the expression flashing on your screen. Select your desired formatting, so I'm using soft blue fill, and then click OK. So in the Applies to field, select your entire beginning inventory row range. So in this template, that is F10 to JP10, and hit Apply. Now you can see it clearly highlighting dates where our stocks falls below 30 days, starting right here on September 7th. So our in-transit row shows that 15,000 units are scheduled to arrive on September 10th. When we originally planned this, we expected it around September 6 or 7, but we encountered a shipping delay, which pushed our actual ETA to September 10th. If we project forward to see when our stock runway drops down to 30 days again, we find it hits that mark on October 7th. Notice that there are no stocks arriving on this date. Our template should be triggering an ETA here, but it isn't. Why? Because when we check row 14, our reorder date, the required order date point is August 8th, which is in the past. Since today is August 26th, that order deadline is already in the past, and our formula is designed not to return units for past dates because we cannot turn back time. Instead, the tracker is alerting us that we are already late. If we place the order today on August 26, it would project an ETA that leaves our stock levels at by 11.95 days, meaning we will survive, but we will have completely eaten into our safety cushion. So this underscores the vital role of row 14, which is the reorder date. If an order needs to land on a specific future date, when do we actually need to sign the BO and submit it to the factory? So we calculate this using a rolling lead time offset formula. Whenever a reorder quantity is triggered, this formula subtracts your master lead time from your target ETA calendar date. So flashing the exact deadline on your timeline when that purchase order must be signed and sent out. For instance, if you want stars to land smoothly on November 12th, your order must be placed by September 13th. So the timeline backtracks automatically, subtracting your lead time from your target arrival date. And that wraps up our structural build. By formatting your tracking files into a chronological time phase row matrix and leveraging these exact formulas, you eliminate the guesswork from inventory logistics entirely. You gain total visibility over exactly where your stock levels are trending months into the future.